Very nice. Guys, 1.3, pretty simple section. It's going to start talking about patterns with powers. And I think that you guys have talked about this before. Math as it relates to powers, or if I say exponents, how many would say, yeah, I've probably heard of that before? Okay. Who can give me an example of a power or an exponent? What do you think, Mariah?
Like 4 to the second power.
4 to the second power, which is implying what?
4 times 4.
Means 4 times 4. You're repeating the multiplication of 4 2 times. So if I said something like 3 to the 5th, if I said 3 to the 5th power, what's that implying?
3 times 3, 5 times.
3 times itself 5 times. Good, Mariah. Okay, so it sounds like we've got some exposure to this, and I think that what we go ahead and kind of review today and make sure we've got hammered down is going to help us for where we really want to go with this today. Okay, so my first question, does everybody have their notes in front of them right now like I have up here? All good? Okay, well, let's roll on this, guys. Our goal today is to use exponents to express repeated multiplication. You're going to hear me talk about repeated multiplication. We're going to do some evaluating of powers. What's the word evaluate mean again?
Check over.
Say it one more time, Mariah.
Check over.
Check over. If I say evaluate 3 plus 7, what are you going to tell me?
Solve it. Answer 10.
You're going to tell me 10, aren't you? 3 plus 7, is that what we said over here?
Yeah.
I didn't hear him. I'm deaf on my left here, remember? Okay. Yeah, so to evaluate, it means just tell me what the value is or the solution to the problem, right? So we're going to look at that. Now we're also going to do this thing called make conjectures. Where are my science people that are really into science? Where are my science people? Oh, come on. Somebody's got to like science in here. Are you kidding me?
I mean, I do.
Grant is a science guy. Have you guys heard the word hypothesis in science before?
Yes.
What's that mean?
It's an educated guess.
An educated guess. It's almost like making up a rule. And then don't you go ahead and test that out a bunch of times to come up with a conclusion? Well, this hypothesis is kind of like a conjecture. We're going to look at some stuff, and then we're going to make up a rule. So a conjecture is going to be kind of like a hypothesis in science, okay? Make sense to everybody? Okay. Well, let's run through this vocab real quickly. I want to tie a couple things together for you and make this pretty easy. But how about a volunteer to read what a factor is for me? Anybody want to read that? Give me a show of hands, please. Go ahead, Taylor.
Numbers multiplied together.
Numbers multiplied together. Okay, so this would be like the numbers that we're multiplying together. Think the example we used in 3 to the 5th. Isn't 3 getting multiplied over and over and over again? Okay, 3 would be like the factor getting multiplied all over again. Okay, what's the word power mean? Go ahead, Savannah.
Number of times you multiply that factor.
Okay, so the number of times you multiply that factor. Okay, want to tie something together right here. All right, somebody read what a base is for me. Number being multiplied repeatedly. Oh my gosh, factors said number being what? Multiplied together. Base said number being what? What I want you to understand is that factors and bases are really the same thing in this section, okay? When I talk about a factor or a base in this section, just assume they're the same thing, all right? Well, then take a look at your exponent. What's it say for an exponent? Number of times you multiply the base. Didn't the power say number of times you multiply the factor? Almost the same sentence, word for word, isn't it? What do you think I'm going to say about the words power and exponent as it relates to this section? Say it again, Savannah. You betcha. They're probably going to mean the same thing. All right? Power, exponent just mean the same thing in this section. Okay? So here's an example. Let's just say I'm using 6 to the 3rd power. Okay? That's a bad looking 3. I'll fix that. There's a better looking 3. Woohoo! What's my base in this valued?
6.
The base is 6. Oh, come on. And base can be used interchangeably with what? Base can be used interchangeably with, or I can say 6 is the factor here, right? Okay. What's the power or the exponent? Guys, here's a question. Here's a question. What's 6 to the 3rd power mean?
6 times 6 times 6.
Would everybody agree with that? So if I write that as this phrase right up here, repeated multiplication, I write it as 6 times 6 times 6, essentially you've dialed up the devil, right?
Yeah.
Get it? 6, 6?
Yeah.
Never mind. All right. I'm by no means a leader of a cult, so. All right. Hey, what if I said evaluate that now?
Solve it?
What is it again, Grant? 216. Yeah, just tell me what the product is. Excellent. Okay, good job, Grant. So, that's a weird looking 216, but I just want to make sure we understand all these properties or these terms right here. First of all, this means 6 to the 3rd power, right? Base or factor is 6. Exponent or power is a 3. We said the repeated multiplication is 6 times 6 times 6. If I would say to evaluate it, the evaluated part down here is what value? 200 and. So as I look at all these goals right up here, didn't we talk about a lot of stuff up here as it relates to just this one example? Are we cool with this? Okay. All right. Well, let's try an example quickly. I think that the first part of this you're really going to roll through. I think the second page is where we're going to see some new things that these exponents will relate to. But in example 1, it says write the product as a power, then how to say it. Okay, so here's what I'm going to put up here, guys. I'm going to write as an example 2 times 2 times 2 times 2. Okay? So raise your hand if you think you know what this is going to look like as a power. You got 3, 5, 7, 9, 11, 13. Effie, what do you think? 2 to the 4th power. Yep, the repeated multiplication is 2. Effie, why a 4 for my power? Yep, 4 2s. 1, 2, 3, 4. Yeah, and I'm quite sure this might be a review for it, and that's okay. And then how to say it. All you're going to do, guys, down here, right how to say it, this becomes 2 to what power? 2 to the what? 2 to the 4th power. Excellent. Excellent. 2 to the 4th power. All right, we're on a roll. Any luck, Mr. Caleb?
Yeah.
You did find some?
No.
No. Okay. Give me about, like I said, 20 more minutes, and
Yeah,
we'll do some
sure.
digging for you. Okay? Sound like a plan?
Just no shirt.
Okay, we'll figure it out. Okay.
Okay.
All right. Thanks, Caleb. What about Grant? Did he find anything?
No.
And
I'm
you-
fine slag either though.
Okay. Maybe ask Brenda to look in his office or Kenda. Okay. Good luck. All right. Hey, you guys try this one on your own. Now, let's make it really tough. Go. On your own. Write that down. I'm sorry, Colton. I hate to make life miserable for you. If I make it harder, you would complain. If it was any easier, you would complain. But I still love all you guys. That's a really neat plus sign somebody made up there today. With the gears. Who needs more time with this example? Anybody?
That's not a plus sign.
Looks like a plus sign to me.
Cross. Yeah.
Cross is a plus sign, isn't it?
No. I guess. No.
I have a good joke for you when we're done recording, okay? All right, what did you put for power?
3.
Yeah, 3 to the 3rd. Yep. Whoa. Guys, I'm not going to write 3 to the 3rd as how to say it. We talked about this in the last section about either the shape of a square or this geometric shape, 3-dimensional. We could say that's not 3 to the 3rd. We could also say that's 3, what's the word I want? What is it? Cubed. Yep. Couldn't I also say 3 cubed here as how to say that? Could I say 3 to the 3rd? Good. I could also call this, I'm going to get fancy with it. I'm so fancy. You already know that this is 3 to the 3rd. Or 3 cubed. IGGY?
Yeah.
Woo. Questions so far? Any questions so far? Pretty good? You can show of hands. How many are with me, at least on the first page? Okay, awesome. Right? All right, so we've got all these terms down. I think we understand. Let's get into the meat of the lesson today and talk about what we're really trying to accomplish. I'm going to go to a new page. Maybe just write this down. Do you have a blank page on the very back? Okay, in your notes, go to the very back page of your notes. You got a blank page there, don't you? Everybody have that there? Okay. I want to talk about something and make sure we understand the difference, because we're going to start running into this a little bit in this section, but a lot more next section. And I want to make sure that we can go ahead and contrast the two topics we're going to look at in the next section. Guys, what kind of a shape is this right here? It's a rectangle, okay? I'm going to put two dimensions to this right here. And I'm going to talk about two terms here, and I want to understand the difference, okay? We have already discussed this term right here. We've already discussed this. Don't tell me what the answer is to that. Don't tell me what the perimeter is to that. But tell me, remind me again, what is perimeter of a figure?
Area.
Not area, but it's the
Distance around.
okay, so Brittany, you're going to say what again? Distance all the way around. So we're just adding up how many sides? 4 different sides, right? Okay, so do you guys agree the perimeter would be a 6 plus a 4? These two sides. Okay, opposite side, what's that going to be? 6. Let me put that in a different color. What are you going to have right here? Okay, so plus 6 plus 4 again, right? What do you get for a perimeter of that? 20. Okay, 20. So the distance around it would be 20 units long. Then we start talking about area. Okay, area is going to be basically, if this was 1 by 1 right here, this is 1 square unit on the inside. Area is trying to figure out how many of these squares right here would completely fill this yellow part. Okay, anybody recall? Yeah, question? Somebody have a question? Somebody have a question? All right, how about an answer for me, Gator?
6 times 4.
Okay, what's your formula for the area of any rectangle? You said 6 times 4, so this is a, what's the word? A length times a width, right? So instead of talking about distance all the way around anymore, okay? All right? Instead of talking about distance all the way around, is that a nice fan for you? I think I threw my shoulder out. Your area is going to be length times width, isn't it? Okay. So in this case, 6 times what? Well, that's a bad looking 6. That might be the worst looking 6 I ever saw. And what's that value going to be? 24. Keeping in mind that areas are what types of units? What kind of a shape is that? Not a rectangle, but these red ones right here, square units, 24 square units, okay? So, guys, I want you to kind of change your thought process of perimeter that we've looked at to area. So I want you to start thinking of length times what? Width. Okay, let's go back to that second page of your notes then, all right? Understanding that rectangles area are length times width. We're going to start looking at what we call algebra tiles. You're going to see a lot of this in your book, and I'm going to kind of give you a toolbox to help you out with this. So, here we go. We kind of talked about evaluating powers right here. A couple of things that we already know up here. We had said x times x can be written the same as x to the what? X times x is x to the second, and we can read that how? X squared. Anything to the third power can be read as what? Cubed. Okay, just keep that in mind, okay? What's most important for you guys today is going to be right in here. You might want to highlight this, do what you need to, but this is really important right here. This part, very, very important for you, okay? That part is going to be very important. In fact, who's got a book handy I can look at right now? Can I take a look in this? I think turn to page 23 and 24 real quickly in your books. Yep, page 23 and page 24. Actually, page 24 would be best. At the top of page 24 when you get it. talk about finding expressions for area with the given shapes. And what I want to get at today is this toolbox right here. This is going to be a toolbox to help you out. Whoops, didn't want to do that. Here's this toolbox we're talking about for you to understand. Okay, what are we talking about now in terms of these shapes? What did I just underline here? What did I just underline right there? Their areas. I want you to talk about their areas, okay? And these are all four-sided figures, either a square or a rectangle. So we got to think length times width. Okay. I want you to label everything as I label them right here. This big square right here, I want you to say that the length is x. Guys, if this is a square, if the length is x, what has to be true of the width? Same thing, x also, right? Okay. So throw those two dimensions in there right there. Okay. Then you've got some skinny rectangles like this. What's this distance, this longer distance, the one going up and down? What's that look like? Doesn't that distance look about the same as this distance? What do you think we're going to call this distance? Okay. And then this shorter distance down here we're going to call a 1. Okay? We're going to call it a 1. All right? And then for these little squares, these are going to be 1 by 1. Okay. Now, down below we've got some areas written for each one of these shapes. Because what we're going to do is we're going to start taking these shapes, putting them together, and talking about expressions for the area of the shape that is formed. Okay? And you'll understand what that means in the next example. But let's come up with an idea of areas for these. Guys, what's the formula I really need to pay attention to for areas again? You just told me it was? I always make a cursive L for what? Times? Hey, check it out, guys. What's your length times your width down here? What times what? X times x. How does that relate to our patterns of powers that we just discussed? How can I write x times x as a power? So the area of any of these right here is always going to be x to the what? Okay, so I'm going to put the area down here as x to the second. Any big squares have an area of x to the second. All right? How about the skinny rectangle? What are you going to multiply together there to get that area? X times 1. What is 1 times anything? That thing, right? So if I take 1 times x, what have you got?
X.
Gnarly. Woo! Ric Flair in the house. You guys are probably too young to know who Ric Flair is, though. Anybody know who Ric Flair is? WWE wrestler? Anybody watch Monday Night Raw last night? Oh, am I the only one that watches that real stuff?
I only like John Cena.
Well, so do I. But I like Sheamus, too. Well, it's good stuff. It's comedy. All right. How about this little square right here? 1 times 1. Did you guys know that my second job is a professional wrestler?
Oh, whatever.
You haven't seen the guy come out with the cape? He's got the big square root symbol on him. His name's a square root of pain. This guy. You know what my finishing move is? Opposite reciprocal. What's 1 times 1 for that area? 1. All right. Nah. Oh, come on. Area's going to be 1. Okay. What I want you to understand is this for your toolbox. What's the expression for the area of large squares? What's going to be the area expression for skinny rectangles in this section? And what's going to be the area expression for the little square? Okay. Do you guys have those 3 concepts down? All right. Are you with me so far? Okay. This is very important to help you understand what's going on down here. We are going to start looking at writing area expressions for figures that are formed from a combination of these 3 shapes up top. Okay? So in the example right here, it says write and what? Write an area expression. Okay, hold on. Write an area expression for the area covered by the tiles, and then we're going to have to evaluate that area for x is equal to 4. First things first, let's write that variable expression. Okay? Here's what I like to do. I just go through and count them. Okay? Let's see, in the toolbox we had some big squares, we had some skinny tiles, and we had some little squares, right? Okay? Talk to me about the number of big squares in there. How many are there? How many big squares?
2.
There's 2 of them. Okay? What I like to do is go through and label these. Big squares. You guys agree my areas of each one of them would be x squared for each of them? Okay. I have some skinny tiles in there. What's the area of each skinny tile? So what could I replace in these skinny tiles? An x, an x, an x, an x, an x, an x, an x. I got some little ones here, right? Some ones, right? Now, here's the dealio. I've labeled every single one now, right? It just becomes a matter of counting now, all right? I always start with the biggest, and I go right in the order. Big, skinny, small. Go in that order. Well, careful on it. Yeah, I agree 4 x's. But let's start with the big squares. How many big squares are there? 2. Okay, and each square variable expression form was x squared, right? How many were there? So to start this out, we're going to say, you know what? There are 2x squareds here. That's this right here, isn't it? You guys agree with that? Okay. Then somebody said we were adding some x's. How many, Zach?
Well, 4.
You said 4 x's. Don't I have 4 skinny pieces up here?
Yes,
4 skinny pieces. That's like Skinny P on Breaking Bad. Skinny P. You guys must not watch Breaking Bad either. Oh gosh, I'm probably a bad influence, right, Savannah? All right, what am I going to add to this right here? 4x. And then finally, I've got some ones, guys. How many total ones down here? There's 2 of them. So what are you going to put on the end, you think? Plus what?
2.
Plus 2. Okay? It's just a matter of counting the shapes, isn't it? Making sure you put in the right variables with the right exponents. You understand how I came up with that? Okay, what's the 2x squared represent again? The 2 biggest squares. What's the 4x represent again? The 4 skinny pieces then, right? And what's the plus 2 on the very end of that variable expression representing? Yeah, pretty easy, right? Maybe make a note down here. Just count the shapes. That's all we're really doing, right? Count the shapes. Do you guys understand how the toolbox is related to this example right here? Do you guys understand? Yes? Okay. All right. Well, then the second thing it's said to do is evaluate for what? Evaluate for what? X equals 4. So everywhere where I have an x in my expression, what do you think I'm going to substitute in there? So let's do some arithmetic. This is going to become 2 times, what's going to take x right there? Okay, I'm going to put a parenthesis around that to indicate I substituted 4. What power is that 4 to? Second, plus 4 times what? Plus what? 2. Okay. All right, let's evaluate this here real quickly. 4 to the second power is what? 16. It means it's 4 to the second, or 4 times 4, right here? Okay, so isn't that 16 times a 2 right there? What's the product of 16 and 2, gang?
What?
16 times 2. Yep. So isn't that first part 32? Here you've got a 4 and 4. So what's that product? And 2. You guys are doing an awesome job of paying attention. Awful quiet out there. Any questions to this point? Anybody? Lauren?
When you do like the 2 and the 4 thing,
Mm-hmm.
where did the 4 from?
Right up here when I say let x equal what value after you've written your expression.
Okay.
See it? Okay, good question. Any others? Lauren's question was, where the heck is this 4 coming from? And if we didn't see it up here, it's coming up here in the directions, right? Everybody cool there? Okay. Hey, I'm not very good at math, so you help me add 32, 16, and 2. 50?
Yep.
Awesome. 50. 50 cent. 50. 50. Guys, this is just a matter to write a variable expression. It's just a matter of doing what? Counting the what? Counting the shapes. How many x squareds did we have in this, guys? And to that we added some x's. How many? And we added some ones. How many? Okay. Let's have you try one on your own. Does everybody have stuff down to that point? Everybody in the back okay? Good? All right. Well, let's rock and roll to that last page. Okay, kiddos. On your own. I'll do my best to draw this. Please don't make fun of my art. I'm not very good at it, okay? start like this. You draw the same thing. This is going to be a big square. Okay, and you get that this should be colored yellow on the inside as well, right? Okay, I'm going to put some dimensions. Well, you know what? I'm not going to put any dimensions to it. What I want you guys to do is this. I want you to write an expression, an area expression. Maybe I should put that up top here. Write an area expression. Whoops. Write an area expression for this. Okay, and then somebody give me an x value to use for the evaluation. Nick, you got a value? 4. Let's use 4 again. Then evaluate when x is equal to 4 here, okay? So go ahead and write an area expression first, okay? Like so many x squares plus so many x's plus so many 1s. And then once you've got that expression written, what are you going to substitute in for x to get an evaluation? 4, okay? Take a minute or so and do that. When you've got a solution, check with a neighbor. If you disagree with your neighbor, what do you need to do? Talk about why you disagree, okay? Make sense? Question, Lauren? Good? Okay. If you have questions, raise your hand. I'll be around and take a peek and help you out, okay? That's good over here. Awesome. What do you think you're in? Too easy? Good deal. Girls okay? Ethan okay? Ethan, you were going okay this week, right? Did you get some stuff in Tuesday? Okay, I want to check and make sure. Looks like we need to finish this one. So do that. How about the book page? Did you turn that in already? Puzzle 1.1. Is that turned in as well? Okay, so I'll double check tonight, and then maybe you and I just talk about what it is you guys turned in. That would be good, okay? Sound like a plan? Excellent. Allie, got a question or an answer? Okay. How many x squared do you have? How many big squares? 1 foot x squared. And to that, you're adding some steamy pieces. How many? 2 what? Yep. And then how many 1s are you using? Here's your expression. That makes sense? So now you're going to stick what in for each x here? 4. Got it? Okay. I'll be real close. I agree with the x squared, but these aren't x squares. How many x's are there? Put that 2 out front here, Mariah, like that. It's 2 x's. Okay? Don't ever change the exponent of them. You're just counting. The number that you count of each piece goes out in front. It gives you the x squared, the x squared. Make sense? Okay. Who needs more time right now? I'll give you about 30 seconds, all right?
I used to look like a kid. Still almost there. Big kid.
I'm a big kid. I can't believe I coached volleyball for a year. That's scary.
2 years.
So I'm going to coach basketball again this year.
Really?
Getting back into it.
Boys or girls?
Girls. Coming out for me, Bree? Come on, we have fun. Seriously, do it. We'll have so much fun.
Are you just Robert's assistant?
I'm just a second assistant, so I would be doing fresh sophomores at the lowest level.
Teachers, please release the cross-country runners at this time.
Okay.
Thank you.
See you, Marcia.
Nice try. I don't even get to go tonight, so.
Why not?
I want to go to Ron Bader's visitation tonight. That's why. So.
Are you going tomorrow too?
Yes. Yep. Yeah, they've been very good to me. Good people. Always liked Ron. Area expression. Who thinks they've got it? Oh, come on. Go for it.
X to the second power.
Yep.
Plus 2x.
Oops, hold on. Let me get this again going. X to the second. You say, oh gosh, what's going on? Time out. Hold that thought. Don't let it go anywhere. Okay, X to the second you said?
Yep.
There we go.
Plus 2x.
Excellent. Nice job. And I love the shirt, by the way. Love the shirt. Glad they won the other day. Well, who said who?
What do you like?
Okay.
You want on?
All right. What am I plugging in for X? Did you find Slack?
No.
Come here. Grab my keys real quickly up on my desk. And there's an orange key and a red key. Take those to get into the track cage. Okay, the orange key will get you in the door. You know where I'm talking about by the locker room, right? Orange and then the small red one, okay? And dig through those totes to find something, all right? If not, talk to Coach. She'll figure something out for you. Okay? All right, so I'm plugging what in for X, guys? So this becomes 4 to the plus 2 times what? Guys, sorry about the interruptions today. Hope you can handle it. It's my 4 squared. What's my 4 squared here? 16. Product of 2 and 4 right here is? 16 plus 8 plus what? How many square units for your area? 25. How many had 25 there? Oh, very good. This is awesome. Awesome. Good job, guys. Good job. So I might write down 25 since it's an area. You might just want to put down the term 25 square units. Okay, excellent work, guys. I think if you can understand this right here, you're going to be in A-OK shape. All right? Huh? Oh, no. No. Okay. Hey, did Columbus stop when he didn't quite get to America yet? No. If Columbus would have just stopped, would he ever found America? No. Would you be here? No. Okay? Can we just stop? No. We can't just stop. All right. We're almost stopping, though, okay? I'm almost ready to stop. Does that make sense? Okay? How many people are just going to go home and show this video to your parents and find out how crazy or show them how crazy I really am? I knew it. I knew it. All right. Here we go. Hey, powers of 10. Okay, that means my base is what value? 10. What's 10 times 10? 100. What's 10 times 10 times 10? 1,000. It's basically take the 10. If I had 4 10s multiplied together, how many zeros would you put into the 1? 4 of them, okay? I want to show you something real quickly. Multiplying powers of 10. We want to come up with a rule or a conjecture about multiplying by powers of 10. Hey, real quickly, guys, 10 to the second times 10 to the third. Just write this down, okay? And I want you to think about your exponents in this right now. What are the exponents in this product? 2 and 3, right? Okay. 10 to the second, repeated multiplication. 10 times itself, how many times? How many? 10 to the second. This part means 10 times 10, doesn't it? Okay. What's this part mean? How many 10s for the second one? Guys, 10 to the second, 10 to the third. Isn't that really saying multiply 10 times itself how many times? Kit's going to be in the track cage, Coach. They've got the keys right down there. I've got it all ready for you, all right? Okay. 5 times, right? So this is really the same as a power as 10 to the what? 10 to the 5th. Guys, look at your 2 and your 3 up here. How would you use the 2 and the 3 in the original problem to rewrite this as 1 power of 10 to the 5th? What do you do with those? Allie, what do you think, kiddo? Exactly. So a conjecture I might come up with would be, if I'm multiplying powers with the same base, what are you going to do with exponents? Are you looking for a uni? Yeah. Green. What would you do with the 2 and the 3? Add them, okay? So when you're multiplying powers of 10, the rule is this. You add your exponents. Add your exponents. Okay? That's the rule. So as an example, listen to this one right here. 10 to the 4th times 10 to the 5th. 10 to the 4th times 10 to the 5th. What's that going to equal as a power?
Oh, big one.
10 to the 9th. What do you do with the 4 and the 5? Add them. That makes sense? Guys, if multiplying powers of 10 meant to add the exponents, what do you think we're going to do if we divide powers of 10? Exactly. Check it out. Let's go 10 to the 4th divided by 10 to the 3rd. Okay? Check this out, gang. How many 10s up top? There's 4 10s, right? 4 10s. 10 times 10 times 10 is 10 times 10. On the bottom, how many tens? Listen up, everybody. When I have a 10 over a 10 like this, what do they tend to do to each other? Cancel. 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 What's that leave you with up top? How many tens? Okay. We get an answer of 10 to the first power because there's only one left, right? What's your conjecture about the 4 and the 3 right here when it's written that way? What do you do with the 4 and the 3 to form a 1 over here? Subtract exponents. So in this right here, when you're dividing powers of 10, you will subtract your exponents. Whoa! Holy cow. That is a big looking T. Yikes. Yikers. Yikey. Exponents. Did I spell this right? Yes, I did. All right. Questions about anything? I want 3 things that you picked up today, just randomly. What did we cover today? What are 3 things that you learned today? What's 1? Nick, what's 1?
The powers.
The powers, okay. What's another one? Go ahead, Kyle.
How to write a expression.
What kind of an expression?
Variable expression.
As it relates to perimeter or area? As it relates to area. Very good. Okay, and then what's the last thing that we talked about? Multiplying and dividing powers of 10. Okay. All right. Hey, you guys did a good job in the notes. I do have a book page I'm going to hand out to you.